Hello, and welcome to another video in Reigate Maths series on the binomial expansion from the second year A-level maths content. This is an extension of the first video where we introduced the new binomial expansion when the power is not a natural number, and now we're going to look at how we deal with questions where the bracket isn't 1 plus x. So if you remember from the previous video, the formula given on the right is only there when our bracket is 1 plus x. But as we well know, this is not necessarily always going to be the case, and the exam boards love to add extensions in. So we're going to look at the two cases for this extension. The first one is not too much of a stretch. It's when 1 plus kx, so we have a coefficient of x. This can also be applied if it's something like 1 plus x to the 2. So the x has a power inside the bracket as well as outside. The second one takes a little bit more work, but is a lot more useful in terms of the exam, wherein they will like to extend this idea further, looking at things like partial fractions, which is what we will be covering in the next video. So for a start, let's have a look at this first example, using the binomial expansion to expand 1 plus 2x to the 5 over 2. Okay, so in this case, n, our power, is 5 over 2, and we can see that instead of having 1 plus x, we've got 1 plus 2x. Now, as I said, this is not too much of an extension, because all we're going to do is, instead of having x in the formula, we're going to replace that with 2x in this case, or whatever this ends up being. So the first term of our expansion is still 1, and the second term is n times our x term, which our x term in this case is 2x. We keep going and we see that the expansion is relatively similar. Now do be careful when expanding this type of thing. Notice how I've been very careful here with where my bracket goes. A very, very common error with this type of example is to forget to square the 2 in this case. We're going to do one more term. So we've got 5 over 2 times a half times 3 over 2 times a half. If you realise your mistake there, you can either do like I've done and just change it very quickly, or just write the 3 over 2 next to it. You're not going to lose marks for having these in kind of the wrong order. So then we've got 1 times 2 times 3, and then we've got 2x cubed. And then we're going to stop there, because going any further than that tends not to be required for the A-level. Again, like I said in the previous video, those of you who do further maths may well look at something called the Taylor expansion, which is an extension of this kind of idea. That's when you start having to go a little bit further, because terms will cancel out, or terms will become 0, and you might need a certain number of terms. But for this, we're okay. So let's have a look. We can see, like before, our first term is going to be 1. And now, unlike before, we can see that our fraction is going to do some simplifying here. So we're going to end up with 5x. Now this is where things get a little bit interesting, and if you can spot the way things cancel out, it can make doing this whole process a lot quicker. Obviously, you could just stick all this in your calculator. But I would say if you can do this quickly, it is generally a lot quicker to do it in your head than on a calculator. So I'm just going to take an aside just up here to explain what I'm doing with this. So thinking about our fractions, this is 5 over 2 times 3 over 2 divided by 2, so times by a half, then times by 2 squared. So I can see that I'm going to get 2 of the 2's cancelling with what's inside the bracket. And you can see I'm left with 5 times 3 times 1 in my numerator, and then just 2 in my denominator. So I end up with 15 over 2 x squared. Here we can see we've got a lot more that cancels out. It's still plus because our numerator hasn't gone minus yet. We can see I've got 2 cubed here, which is going to cancel with the 1, 2, 3 2's I've got up here. We've got the 3 cancelling with the 3 here, so I'm just left with 5 over 2 x cubed. The last thing we need to worry about is the validity of this expansion. So if you remember, for our normal expansion, the validity is when modulus x is less than 1. In this case, we can instead think about it as the x term. So we say this is valid for the x term, which remember is 2x, is less than 1. Simplifying that, we get the modulus of x is less than a half. So unlike before, if we had x is say 0.7 and we were trying to use this to get an approximation for something, this expansion would not be valid. If we had x is minus 0.3, it would be, because x is between minus a half and a half. And that's it. As I said, this extension is not too onerous. It's not too much extra on top of what we've already done. The next example, however, does require a little bit more. So the next example we're going to look at is if we're doing with 4 plus x to the half. The problem with this one is the expansion as it stands is only valid for 1 plus x. So we need a way to change this 4 to a 1. And we do that by taking it outside of the brackets. So this first step I'm going to write down is not required for the working of the exam, but I'm going to write it down to show you what's going on. So if we take 4 outside our bracket, this becomes 1, and then we get x over 4. And then this whole thing is to the half. Because the 4 started inside the bracket, it still has to be to the half. So when we expand those square brackets, we end up with that, which is the first step I would expect to see in the exam, or in a less extended answer. So we can see here 4 to the half is 2, and now we have 1 plus something to the half, which we now expand in the normal way. So our first term is 1, our power n is a half, and our x term is x over 4. So it becomes like the example we just did. We keep going, we have a half times minus a half all over 2 times x over 4 squared. And again, like before, we're going to go one more term. A half times minus a half times minus 3 over 2 all over 1 times 2 times 3 x over 4 cubed. This is a very, very important step in terms of the exam. The examiner must be able to see that you are able to use the formula, and this shows use of the formula. I didn't need to write n minus 1 here or n minus 2 here. This shows that I can do that because I've got the right numbers. If you're worried that you're going to get it wrong, then do make sure you write it, but typically this is sufficient. What we need to do now is tidy this up and then finally expand out the brackets. I will always deal with the inside first, but you may want to just expand using this number first and then do things from there. I tend to find I get confused if I do it that way, but that's me personally. So I've got 1 plus an 8x minus, because I've got 1 minus here, so I've got 2, 4, 8 then times 4 squared. So this is where you might start wanting to use your calculator. 2 cubed times 4 squared. It's going to be 2 to the power of a lot. Okay, so it's minus 1 over 128 x squared. Now we've got two minuses, so this is going to be a plus. We can see the 3's are going to cancel. Then I'm going to have 1/2 times 1/2 divided by 2 times by a quarter cubed. So I'm going to get 1, 2, 3, 4 2's. And then, so 2 to the power of 4 times 4 cubed. Comes out quite large, but that's okay. Quite often with the binomial expansion, particularly when you've got this type of question, you end up with quite big numbers. All that's left to do, or quite big denominators, so small numbers. All that's left to do is expand it out. 2 plus a quarter x minus 1 over 64 x squared plus 1 over 512 x cubed. And again, we could have kept going, but we didn't need to. So on the whole, it's only this first step that's different. The rest of this is still just using the formula, and that's the nice thing about these questions. Again, the validity here is a little bit different. So this is valid for the x term less than the not x term. And that's kind of it. If you're happening to do an expansion that requires 2 of these, so maybe we took the 2 answers we've got up here and multiplied them together to get up to the first x, after the first 4 terms of that expansion, we have 2 validities. You choose whichever one is smaller, so in that case it would be this one, because this is a smaller interval than this one. So just before we finish this video, we're going to extend this example a little bit. Now this next part is very similar to some of the extension ideas you had in the first year, but they tend to be a little bit more tricky. So we can see here that we've been asked to use x equals 3. Remember, that is valid for this expansion. The expansion is valid for x is between minus 4 and 4. To find an approximate value for root 28. The problem with this is a lot of students will just go, oh, well, I'm just going to stick 3 in and that's my answer, without really paying attention to what we're doing. So you've got to be careful. So that is, in essence, what we're going to do, but we need to think about it. So if we stick 3 into our expansion, we're getting 4 plus 3 to the half, which is root 7. This is not the root 28 that we've been asked to find, but this is linked to it. So we can use our expansion immediately to find an approximate value for root 7. Okay. Typing this in our calculator, we get 2 plus 3 over 4 minus 9 over 64 plus 27 over 512. Okay, and we get an approximate value of 1,363 over 512. So root 7 is approximately that. What we need to do now is link this to what we've actually been asked to find. So this is the thing that students tend to miss about this question, is they'll just go, oh, I'm just going to stick it in the right hand side and I'm done. No, we've got to think about it. So root 28 is root 4, root 7. So this is 2 root 7, which is going to be approximately equal to 2 times the number we just got. So it's not exactly the same as that. So if we times it by 2, unsurprisingly, we get 1,363 over 256. But that's not what the question is asked for. The question is asked for 4 decimal places. So we need to make sure we give our answer correct to 4 decimal places. So in this case, we get 5.3242, which sounds about right. Don't forget, root 28, or being able to think about the approximate size of square roots, is really useful for this type of question. Don't just look at your calculator and go, that's correct. Actually think about it. For instance, with this example, 1363 over 512, we know, or you can work out, that's 2.66 and a bit. If you think about it, really think, 28 is between 25 and 36. So root 28 has got to be somewhere between 5 and 6, which is definitely not 2 and a bit. So you can use this and really think, okay, what am I actually trying to find, and what approximate value is that going to take? That's going to really help you judge whether your final answer is right. Just looking at this, I can see 28 is pretty close to 25, so my answer is going to be pretty close to 5. It's going to be closer to 5 than 6, which it is. This one, 2.66 and a bit, we can see 7 is between 4 and 9, and it's closer to 9 than 4. So this is going to be closer to 3 than 2, but it's going to be somewhere between. This is really important for this type of question, is being able to judge the approximate value of what you're trying to find. Because it means that when you look at your calculator, which for a lot of questions like this, your calculator will just give it to you as a fraction, you really need to kind of have a look and think, is that right? Have I typed things in correctly? Does the answer make sense? So this is a really common error with this type of question, is just looking at this and going, oh, it's that. Look at the number of marks that this is worth. This question would probably be worth 3 or 4 marks. This is not 3 or 4 marks of working. That's maybe 1 or 2. So you've also got to think, well, actually, have I done enough working to get all the marks? In this case, there's nothing more I can do with what I've done. I can't simplify this anymore. I can't do anything else to it. So clearly, this is not enough. I need to do something else on top of it, and that's this bit. So watching for things like that and being careful is really useful, again, to help make sure you don't miss out on correct marks. Thank you for watching.